Are we live, Vishal?
Didn't got any message from you. He's not replying. What should do?
Yeah. Message on the WhatsApp.
Vishal, I think we are live. It's going on YouTube.
Okay.
Okay, please mute yourself.
Okay.
Hello and welcome. I'm Anamika Chhabra, the instructor of the Machine Learning Foundations course, and I'll guide you through the details of this course, which is also called MLF. There are 3 professors who have recorded lectures for this course. Professor Arun Rajkumar has covered optimization lectures. Professor Harish Guruprasad has delivered calculus and probability lectures. And Professor Prashant has covered the linear algebra content. Tentatively, these are the instructors for this course with whom you would be interacting over this course or live sessions. Okay, now let's get to what the course comprises of and why it does so. You might know that almost all products from companies such as Facebook, Amazon, Apple, Netflix, and Google, which are popularly called FANG companies, use machine learning algorithms at different levels. And we all know that these companies have transformed our lives for better. So this inspires us to understand how these machine learning algorithms work. And not only do we want to understand them, we also want to become an expert in machine learning, right? That's why we all are here. Now let's talk about what all is required to be an expert in machine learning. Fortunately or unfortunately, we need to have strong fundamentals. And these fundamentals are linear algebra, calculus, optimization, and probability. This is precisely what is covered in this course, Machine Learning Foundations. And that is why the prerequisite courses for MLF are Maths 2 and Stats 2. You might probably be thinking that linear algebra, calculus, and probability is something that you had covered in the prior courses of Maths and Stats. Then why is the need to do them again? To give you some perspective, the basics of linear algebra and calculus you would have done to some extent in Maths 1 and Maths 2, and probability you would have done in Stats 1 and Stats 2. But the difference that MLF will bring in is that in prior courses you learn these topics from a very general perspective, whereas in MLF these topics will be taught from a machine learning perspective. These topics will be connected to where they might be useful in ML algorithms. Moreover, some topics for which you learned only the basics, now you would be exploring them in much more detail. Also, optimization is something that you wouldn't have done in the earlier courses, so this content is going to be completely new for you. We came across many students in the past couple of terms who expressed why there is yet another course on fundamentals after they had already gone through other primitive courses. They seemed quite eager to get into action and build models directly. So what I would like to highlight here is that courses such as Stats 2, Maths 2 are completely conceptual, which you would have seen so far. Whereas the courses such as ML techniques and ML practices that you would be taking in the next term after finishing MLF are completely ML based, where you would directly start building models from week one itself. So it's really important to bridge these completely conceptual courses with the completely ML based courses, which is what MLF is doing here. MLF course will introduce concepts and will connect these concepts with ML algorithms here and there. So you can see this course as an extended foundations course, and it provides you one more term to explore things before you actually delve into coding things. I'm sure many of you would think, what's the need for understanding fundamentals when you can directly use some libraries and can really see things in action? It's important to understand that being able to use some inbuilt libraries and observing the outputs is not what data science involves. That is just a small part of the whole data science. Just like a building is incomplete without its foundations, the journey of a data scientist is also incomplete without having a strong foundation in the fundamentals. Moreover, the libraries that you are using today might not be used tomorrow, right? These libraries keep changing very quickly with time. This you would have seen in the past. So you don't want to be outdated in the times when the libraries that you were experts in are no more prevalent. So you should have the capability to write these libraries on your own. If you're able to do that, then you can call yourself a true data scientist. Maybe I can also add some of the feedback received from the students who finished MLF. They said that after doing MLF course, they are now better able to connect the dots and able to see why linear algebra and calculus, etc., are important to understand machine learning. Similarly, the students who finished MLT and MLP courses said that they now understand why MLF course is introduced just before MLT and MLP and how it helped them to understand some of the underlying details of ML algorithms. So the takeaway is to gear up to study these topics even further and be better equipped to understand the ML algorithms in the upcoming courses. Also, since this course is a digest of 4 elaborate courses, you might need to explore here and there if you wish to delve deeper into any of the topics covered in the course. It may also happen that given the diversity of the student pool, they might find some of the topics to be a recap of what they have already studied. But that should be okay, given that the topics are important for ML. Refreshing them also may not be a bad idea. So it all depends on you, how you wish to make use of this intermediate level before proceeding further to ML techniques and ML practices courses. Now let's briefly see the topics covered in each of the weeks of the course. Week 1 will give a broad and basic introduction to different types of machine learning techniques, such as supervised and unsupervised machine learning. Well, for each week, let me also convey how the students from previous terms found the content of these weeks so that you know when to keep yourself free to handle difficult weeks. So week 1, since it's a basic introduction to ML, students found it quite easy. Week 2 will provide you a brush up of the calculus concepts. Calculus plays an integral role in understanding the internal workings of machine learning algorithms. For example, differential calculus is extensively used in optimization of different loss functions. And optimization is one of the important steps in building an ML model. Since many of the calculus concepts you would have studied earlier, you might find this week to be an easy week. Third week is when linear algebra starts. It introduces vector spaces and also covers least square regression that is used to find the best fit line through a set of data points. The difficulty level of this week is moderate. Week 4 introduces a very important linear algebra concept, which is eigenvalues and eigenvectors. Now, this is something that you might not have done in prior courses and is quite important in understanding some core ML concepts. For example, in data science, we sometimes need to reduce the number of features. For that, we use a technique called PCA, which is Principal Component Analysis. Now, PCA makes use of a matrix concept called singular value decomposition, also called SVD. Further, SVD uses the eigenvalues and eigenvectors of a matrix. So you see how different core ML concepts backtrack to some of the basic concepts from linear algebra. Okay, the difficulty level of this week you might find to be moderate. Week 5 covers complex matrices and SVD. This week was perceived to be a difficult one by the students in the past. Week 6 introduces and goes in detail of PCA. Again, another difficult week. I should highlight that weeks 5 and 6 were found to be the most difficult by the students who have taken this course in the past. And these two are the weeks where the difficulty level actually peaks in the course. So you might want to keep yourself probably free from other engagements to be able to spend more time during these 2 weeks. Moving on, week 7 is when the optimization content will start. As I said earlier, one of the important steps in ML modeling is to find the values of parameters that minimize an error function, which is precisely called optimization. You might find this week easy as well as interesting, as it introduces one of the important optimization techniques, which is called gradient descent, right from scratch. In machine learning algorithms, we prefer to take those functions as error functions that are convex in shape, so that any local minimum is also a global minimum. This week, week 8 will introduce different properties of convex functions. This week will have a moderate difficulty level. Now, there are 2 types of optimization techniques, unconstrained and constrained optimization. While week 7 covered unconstrained optimization, this week 9 will focus on constrained optimization and Lagrange multipliers. The difficulty level of this week was also perceived to be moderate. Finally, the last 3 weeks focus on probabilistic concepts. Week 10 will provide you a basic overview of some probabilistic concepts. Most of these you would have done earlier. So you may consider this week to be a refresher with a very easy difficulty level. Week 11 will introduce different kinds of distributions such as Bernoulli, Gaussian, Poisson, multinomial, etc., which are quite useful in knowing about the data and hence accordingly applying appropriate ML techniques. This week will have a moderate difficulty level. The last week is on an important ML concept called expectation maximization, which is a method that helps in determining values for the parameters of the model. The parameters are found such that they maximize the likelihood that the data was produced by the process described by the model. So this is a very important concept. Since this week will bring in a new concept that you may not have done earlier, the perception for this week can be said to be difficult. So that was about the topics that you will study in this course. Now let's talk about the grading policy, which will not be very different from the courses that you would have done earlier. As there is no programming component in this course, the evaluation will comprise of 2 quizzes and the final exam. The types of questions will be MCQ, MSQ, and NAT as usual. The effort requirement for this course will be close to 3 hours of video watching, working on activity, practice, and graded questions, and 2 to 3 live sessions per week. Lastly, I would like to suggest you to take this course as an opportunity rather than a compulsion to study more fundamentals. Getting back to the effort requirement, based on my past experience on this course, I would like to add that different students spend variable amount of effort on this course. There are some who just remain confined to only what is covered in the lectures, while there are others who get started with what is covered in the lectures and go out and explore more. So you see, this course is a mixture of 4 very important courses. So there's no limit on how much you can explore. I would end the introduction to the MLF course now. We are excited to have you on board and interact with you on.
So that was the introduction to ML Foundations course. I'll now request Swarnim to take over and proceed with the introduction to ML technique and ML practices courses.
Thank you, Anamika. Okay, is my screen visible?
Yes, it is visible.
Okay. So, greetings and welcome to the orientation program of machine learning techniques and machine learning practice.
Looks like there's some technical glitch at Swarnim's side. He's joining soon. Thanks for your patience. Swarnim is joining just in a couple of minutes. Okay. Meanwhile, as Swarnim joins, Vishal, can we take up some of the questions from the Google form regarding MLF?
Yeah, sure. I'll just pick out the questions. I'll just go through that.
Yeah.
So the first one is somebody is asking what is the expected time to spend for a week?
Okay. So I think that was covered in the
Yeah.
presentation for ML Foundations. Yeah, so there'll be close to 3 hours of recordings, video recordings, and there'll be 2 to 3 live sessions, and the amount of time that you will spend in working on the activity graded and practice questions. So that's a bare minimum, I would say. And if you wish to explore a little more, as I said, it's not possible to cover 4 courses in one course, right? Some of the things you have started with in the previous courses, but then once you go through more things in this course MLF, you might want to delve deeper. So that's up to you. If you wish to do that, then you would require a little more time. And another thing, like I mentioned in the presentation about the difficulty level, which is variable for different weeks. So there are some weeks which are quite easy, so you might very quickly finish them off. Whereas some weeks, like I said, weeks 5 and 6, they are the difficult weeks. So the bare minimum number of hours might not be really sufficient for these weeks. So you might want to plan accordingly. You might need to spend extra time because probably in one go you might not understand the concepts, and you would have to go through them again. So that depends. So it's not fixed, it's variable. Accordingly you can plan. Yeah, Vishal.
Yeah. So the next one is, what would be your advice so that we can gain maximum from this course?
Okay. Okay, I think that's also a good question. So I think that also I pointed out in the presentation. It's a sort of an intermediate level course, and there might be some people who would, again, I mentioned this, some people would quickly want to do coding, right? But that's a very surface level knowledge. The internal details understanding is very important, which is what this MLF provides you as an opportunity. So if you wish to do well in your journey of learning machine learning, I would suggest you to go in depth of the concepts that are covered and also beyond that. So, in the next course, ML techniques, an algorithm will come in every week. Okay. So if your fundamentals are strong, you will quickly be able to grasp those algorithms. So I would suggest you to spend a good amount of time on this course. That will help you do well in this course, of course, as well as in the forthcoming courses. Yeah.
Okay. So more or less all the questions seems to be related to, like, is stats 1 and stats 2 enough for this course, or will there be any more stats content?
Okay. Okay. Stats 1 and stats 2. So as I said, probability is there in ML Foundations, which comprises of 3 weeks. Out of which first week, which is week 10, you can just consider as a brush up of probability. So that's an easy sale. Then week 11 and 12 will bring in new things. Week 12 is something that is completely new for you, seeing what you studied in stats 1 and 2. So maximum likelihood estimation, which is an important topic, is being covered in week 12. So that's completely new. So getting back to your question, will there be new things in MLF as compared to stats 1 and 2? Yes, there'll be new things. There'll be some brush up of old things as well as new things will be there. Yeah.
Yeah. So by now, I guess there is no more question, but more or less the questions are related to which combination they should take if they are taking MLF. So this and yeah.
As in, along with MLF, which other course they should take, is it?
Yeah. So this is one query regarding.
Okay, I only know a little bit about other courses, like TDS is there, I guess. In yesterday's session, there was this discussion that TDS is comparatively an easy course. So since MLF would require a good amount of effort, probably you might consider pairing that up, MLF plus TDS. Well, it also depends on other courses that you have taken so far. So I think I might not be able to comment more on this. Well, meanwhile, any more questions, Vishal?
No, ma'am. So more or less all the questions are related to practices and theory. So MLF, I can't see much question.
Okay, so if you have this question on the combinations of courses that you should go for, maybe you should elaborate a little more on what all you have taken so far, and maybe pose a fresh question on the in the form, and we will take a look at it, and we'll take all the further queries after the presentation on ML techniques and practices. Swarnim is here. So Swarnim, are you ready with the presentation?
Yes, my apologies. There was some network issue. So could you please tell me till what slide or what topic I discussed?
You should start over, Swarnim, right from the beginning. Yeah.
Okay.
Okay, over to you, Swarnim.
Yes. 1 minute. I need to get permission for sharing screen.
Okay, meanwhile, I can see one more question on the in the form. Why are two different subjects of ML? MLP is understandable, but how are MLF and MLT different? What's the big picture? So I think you wish to know the difference between the courses MLF and MLT. So in MLF, MLF is a theoretical course. There's no coding component. Whereas in ML techniques, it's all coding based, where you would be implementing the ML algorithms in Python from scratch. Okay, so that's a huge difference. ML Foundations is a completely theoretical course, sort of an extension of Stats 1 and Stats 2, Maths 1, Maths 2. Whereas there's a whole lot of coding in ML techniques as well as practices. So that's the difference.
Okay. I hope my screen is visible.
Yeah, it's visible.
So sorry for the disturbance. Welcome again for orientation of machine learning techniques and practices courses. It will be taught by Dr. Ashish Tendulkar, who is a machine learning specialist and currently working in Google. He has worked over 14 years in various domains of machine learning, deep learning, and natural language processing. This is the team of instructors that will be conducting this course. Amrita, Arun, Anamika, Devjyoti, Jimmy, Karthik, Nitin, and myself. So the first question that comes in is, what will be covered in the machine learning techniques? So there are three techniques that we'll be covering, or rather three problems that we'll be covering. One is the regression, second one is classification, and third is clustering. In regression, we will be covering two types of techniques. One is linear regression, the other one is polynomial regression. In linear regression, what we want to do is we want to just fit a line given the data features. In polynomial regression, what we do is we introduce polynomial features using the features available in dataset and try to create a more powerful model. However, with more powerful model, there is a possibility of the model, instead of learning the underlying pattern, it tries to remember each and every point, and that is not what we want. So this kind of situation is called overfitting, and we try to handle overfitting with the help of regularization. And all this will be covered in week 2 to 3. Next problem that we will be studying is classification. And the techniques to address classification problem will be least square classification, perceptron model, naive Bayes, and there's one more which is logistic regression. All of this will be covered in week 4 to 6. So classification differs from regression only in the predicted label. In classification, we predict discrete number of labels. In regression, we predict continuous value. Apart from the techniques mentioned in the previous slides, we are going to also take a look at KNN, which is K nearest neighbor, linear support vector machines, as well as non-linear support vector machines to tackle classification problem. And these techniques will be covered from week 7 to week 8. The next very popular technique that we are going to study is decision trees. It is widely used and one of the most explainable models that explains its popularity. Then we are going to use bagging and boosting, which are techniques by which you can actually create very powerful models by assembling a bunch of models. This will be covered in week 9 and 10. Week 11 will cover clustering. There are two types of techniques that we'll be studying, K-means and HAC, hierarchical agglomerative clustering. Clustering differs from regression and classification in the sense that it is unsupervised problem. That means we don't have the labels associated with every sample. The last week will cover the fundamentals of neural networks, backpropagation, now one natural question that comes into mind is, does this course have any programming component? So the answer is yes. Every topic and technique that you will be studying in machine learning techniques will have three aspects to it. One is the intuitive idea. Second is mathematical concepts associated with the topic. Third one is the programming component. So for every technique or any model in any of the weeks, we will be introducing the idea, what is the model, how is it trained, what are the necessary mathematical foundations or concepts necessary, and we are going to write code for it. So this is a very good place for you to roll up your sleeves and get your hands dirty in programming. Next question that is very important is, how much effort do you need to put into this course per week? So for every week, there will be some video lectures. We will conduct live sessions, as well as there will be assignments, activity questions. Then there are practice and graded questions, both theoretical as well as practical. Practical in the sense you will have to write program to solve those questions. Now coming to machine learning practice. This is an example that my colleague likes a lot. So this is a very intuitive way to make a comparison between what you do in a kitchen and how machine learning foundation techniques and practices are related. So machine learning foundations is the course where you learn your ingredients, the fundamental items, machine learning techniques, You'll put those ingredients in proper manner, proper format. You'll create algorithms or study the algorithms that have already been created and implement them from scratch. So you don't just know the mathematical fundamentals, but you will also know how to implement them using machine learning technique. The last one is machine learning practices. So machine learning techniques and practices differ in their theme. In machine learning technique, the focus is on a technique, a topic or algorithm or a model. You want to see how the model works, what is inside it, what are the advantages and disadvantages of that model. In machine learning practice, the focus is on solving a real world problem with real data. In machine learning techniques, you assume that the data is very well sorted, integrated, and very little amount of pre-processing is needed. In machine learning practices, since we are dealing with real world data could have missing values, it could be completely unscaled, it could have categorical features and other problems associated with it. And ML practices will also learn how to handle these kind of problems of data. In machine learning technique, you will be implementing the models and algorithms from scratch, predominantly with NumPy library. We will use very slimmer of sklearn library. In machine learning practices, you will be extensively using scikit-learn library. So this is what comes with solving real world problems. When you're solving a real world problem, you do not want to implement every algorithm and model from scratch. You want to make use of a very robust and good library, and therefore we are using sklearn for machine learning practices. What we are going to do is, for writing programs tackling real world data, you are going to write code in, of course, in Python using sklearn library in Google Colab platform. So you don't need a very powerful machine. Okay, all you have to do is log in your Gmail account and create a free Google Colab, and there you can download dataset in that runtime, write your code and see the results. Next very important thing is how is the grading policy. Since these two courses have a programming component to them, therefore, in addition to the two quizzes in the final exam, as you have seen in machine learning foundations also, there will be two proctored programming exams also. So what kind of questions will be there in the assignments and final term exam? There will be MCQs, MSQs, NAT, and programming questions. And that's all from my side. Thank you. Okay, Anamika, I think we can now address the questions. Is that right?
Yeah, Swarnim, we can take the questions. Do you want me to pick the questions and speak so that you can answer?
Sure, that will be great.
Okay, give me a moment. Okay, one question is, by completing machine learning theory and machine learning practices, will I be ready to attempt the ML competitions on platforms like Kaggle?
The answer is absolutely yes. However, to just a word of suggestion, then when you're solving the real world problems which are available on Kaggle or any other platform, you don't want to restrict yourself to just one library, which is sklearn. You would want to use Keras, TensorFlow, PyTorch, or any other library that you should fit. So there will be just one idea that I would like to add is, conceptually you'll be absolutely ready to tackle any data science competition. However, just one thing that I would like to add is, you might want to try PyTorch or TensorFlow like libraries, which are very powerful implementations of neural networks and very advanced variations of neural networks also. However, in this machine learning practices, we'll be sticking with sklearn library only.
Okay, Swarnim, this is a general question. Maybe you can speak a bit on this. What would be your advice so that we can gain maximum from this course?
Okay, so my advice is, since you have already gone through machine learning foundations, which builds the mathematical, essentials for solving or implementing machine learning techniques and machine learning practices algorithms. To get maximum out of this is, I would suggest practice as much as possible. Since there's a programming component associated with both these courses, try solving problems on your own. And there's one idea which helps me a lot when I'm learning something which needs programming is I never copy code from Stack Overflow or any other place. Even if I can see it, I definitely refer to those sites. But when I refer to those, I type the code from scratch, from start to end. At least when I'm learning, when the code and the idea is not internalized, that helps.
Yeah, that's a good point, Swarnim. Okay, next question is an important one because many students had this question yesterday's session. So they're asking, is it recommended to take MLP along with MLT, or is it okay to take it one term after taking MLT?
It's perfectly fine to take ML techniques before ML practices. You can take both of them in separate terms. So would I recommend it? It's absolutely up to you how many hours you can spare and how many other courses you are planning to take with ML techniques and practices. Since ML techniques and practices both are programming oriented courses, I would suggest that it would require considerable effort from your side to master both NumPy as well as scikit-learn libraries. So please keep that in mind.
Okay, next question is, although you spoke about it during the presentation, but maybe you can speak a bit more. How is machine learning theory different from practice? Also, how can I do both subjects at the same time?
Okay. So I'll answer your question, first question, how machine learning techniques is different from machine learning practices. So in machine learning techniques, you focus on individual models to tackle one of those problems, regression, classification, or clustering. In machine learning and in techniques course, you will be implementing the algorithms from scratch with NumPy. Okay, so that is one thing. Second thing is, in machine learning techniques, we assume that the data is nearly perfect. There are no missing values and things like that, because our focus is not the data or trying to identify the pattern from the data, but the focus will be on the model or the algorithm that that will be covered in that particular week. In machine learning practices, these two assumptions are actually not true. Machine learning practices, you will be working on real world data, and the data comes in variety of situations. It is either incomplete, there are values which shouldn't be there, so they need some pre-processing. You might even have to integrate data from multiple sources into one, and things like that. And the second point is, in machine learning practices, since the focus is on solving the problem without worrying about whether you have implemented the algorithm from scratch or not, you're going to use standard machine learning library, which is sklearn. So you can just directly import linear regression or regression models, classification models, clustering models right away from the standard library within a few statements, and then you will be ready to apply it on the data set. So you wouldn't be spending almost zero time. You will be spending almost zero time in developing your own algorithms. You will be just using the standard ones. That will be focus on machine learning practices. And since we are at this point where we are discussing libraries, I'm just going to reiterate this point. In machine learning techniques, we will be using NumPy extensively. Okay, all the vector operations, linear algebra operations that you've learned in machine learning foundations, those concepts, those ideas will be implemented with the help of NumPy arrays or NumPy library. That will be in techniques. In ML practices, you will be just using sklearn. And on need basis, you will touch scikit-learn or pandas. Sorry, you'll be using scikit-learn extensively in practices and touch NumPy and pandas as you need them. And the second part of your question was whether you should take these together. Well, you can of course take them together. Machine learning techniques is core requisite of machine learning practices. So either you can take both of them together or just machine learning techniques, and then in the next term you can plan ML practices.
Yeah, okay, Swarnim. Next question is, what's going to be the difficulty level of this course? I think to some extent you told. He's further asking, will it be mathematical like MLF or more of coding? Is it advisable to take MLP with MLT and BA? So looks like 3 questions by the same person. Okay, let's go step by step. What's going to be the difficulty level of this course?
Right.
Okay.
So as I said earlier, both of these courses are, they have a programming component to them. Therefore, you will be spending considerable amount of time writing code and solving problem. So all the things that are associated with programming will definitely come into this. For example, debugging a program, dealing with the runtime errors, dealing with silent errors, and so on. So the logics, the algorithms, they will not be difficult, but implementing them for the first time takes considerable amount of efforts. So yes, it will be a bit programming heavy. And in practices, since you will be tackling real world data, you'll be writing code to pre-process data, then apply your model, see its result. There is a complete machine learning pipeline or end-to-end process that you'll be following, and which takes many iterations to come up with a very good solution or a very good model. So again, there also you'll be writing a lot of code and running on data set and see the results. So both of these courses are will be focusing considerable amount of time and effort on programming.
And the next part of the same question was, is it advisable to take MLP with MLT and BA?
Sorry, MLT and MLP or?
With the BA, Business Analytics.
I don't think I can answer about business analytics course.
Yeah, okay. Yeah, we can skip this. All right. Yeah, next question is basic knowledge of, will basic knowledge of Python be enough for MLP, or we have to be thorough with it?
Good knowledge of Python, I would say, would definitely be handy, along with object-oriented programming. In ML techniques, you will be learning a very important library, which is NumPy, and we'll be providing the resources for that. In machine learning practices, you will just be learning scikit-learn library, and we learn its APIs as we go along. There are many good functions which are available there. NumPy and scikit-learn, both of them are based on Python. So we'll be writing code in Python, and these libraries will be used. So good knowledge of Python is very essential. It would be really good.
Okay, what kinds of hands-on projects can we expect in MLP?
Okay, so in machine learning practices, a real world data will be what that you will be working on. It could be either a regression problem or classification problem, and there you will be applying the techniques or the APIs available in scikit-learn and seeing its results. You will try to see if your model is working fine or not. Do you want to tweak it? Do you want to make it more powerful? Whether it is underfitting or overfitting. Then you will be applying cross-validation for hyperparameter tuning and so on. So basically, you will be working In practice, it will be like working on a real world data set to solve a problem. And the entire process of machine learning and start to finish is what you will be following. So it will be a great experience and kind of what we want you to achieve to learn what are the steps in machine learning to solve or tackle a real world problem.
Okay, next question is quite relevant one, although you spoke about it, but let's highlight this again. The question is there any special preparation required before starting this course? Example practice of Python? If yes, then which library I have to prepare? So this is something that should be highlighted well. So maybe you can reiterate this one.
Right, absolutely. So for machine learning techniques, you can start practicing with NumPy library. So being well versed with NumPy is going to be very, very useful throughout the course. And anytime you are working with real world data, NumPy library comes in very, very handy. So my suggestion is that start working on or learning a NumPy library, brush up your Python fundamentals, and we will be providing you material for learning NumPy library for sure. You can start from there.
Okay. One question is, will we be required to solve a lot of numerical problems with hands like MLF in MLT course?
You will definitely be required to solve numerical problems, but the entire focus will not be on those itself. You will also be asked to write code for that algorithm or that approach and let machine solve the problems for you. The focus will be divided into solving numerical problems as well as writing code for solving those problems.
What is expected number of hours to spend for a week?
Sorry, what is the expected number of hours
required to be spent in a week?
That's a bit subjective. It depends upon your comfort level with programming and the libraries that you'll be using. The concepts and ideas, they will not be complex. They would be easy to grasp. It is just that implementing those either with NumPy or solving a problem with a scalar, both of them require patience and writing a lot of code.
Okay, Swarnim, there is a little different question. Maybe we can take this as well. This course will have a practical component and consequently an OPE. It may so happen that I have to move out for pursuing my master's and I have to share a room in a hostel, and every institute does not have an individual housing for students. How am I going to manage that? Something like that he's asking.
Okay, so there are many students of this program who are actually living in hostels, and they are sharing rooms in places, and they are still taking online proctored exams. So I don't see any conflict between a shared housing and taking these exams and this course.
Yeah, okay, Swanim, rest of the questions are like the combinations of courses. Which course should I take along with MLP, MLT, and those sort of questions only.
Okay.
So I think you've already explained the expectation from both the courses. I think maybe they can take a look at the rest of the courses and then accordingly decide. I think that should be
right. Thank you, Ramika. All right. So if there are no further questions, should we close the session?
Yeah, so Swanim, I just took a look at a couple of chat going on YouTube.
Sure, sure.
So there's a person who is again asking this question. I want to take MLP plus MLT plus BA. Will it be fine? So Yogendra, we've already explained the amount of effort that is required in these courses, MLP and MLT. In fact, there will be some students who, given their other engagements, will be only taking ML techniques in this term and ML practices in the next term. So it also depends on your other engagements, whether you're working professional or you're student, or I mean, like depending on how much time you have to spare. So firstly, it depends on that. Plus BA you are thinking. So this looks like these three courses will take up a good amount of time. So maybe you can accordingly decide, looking at the orientation of all these three courses, BA as well. Okay, is MLT mathematical or computational? Swanim, you want to answer that further? Is MLT mathematical or computational? There are a couple of people asking.
Right. Okay. It's mathematical or computational? That is the question.
Yeah. Yes.
Okay. Okay. So it is actually both. So bit of mathematics, and then we write algorithms and programs to do the computation for us.
Yeah, again, there are other questions on the combination of subjects. I think there is a separate, platform where you can get more details on the combinations of courses. So maybe you can pose your questions over there. I think, Swanim, that was it. I think we have handled most of the questions by now.
Okay, great.
So I think there are no more questions. So maybe we can close this, right, Swanim?
Yes, Anamika, I think we can close now.
Okay, thanks everyone. Thanks everyone for being there. We are excited to see you there. Take care.
Thanks, Anamika. Thanks, everyone.